welcome to today's crash course on physical and chemical changes. Now, this video is mostly meant for secondary 1 and 2, but if you're in secondary 3, 4, and 5, you can also use this as a really awesome review. So in this video, we're going to be talking about the differences between physical and chemical changes, as well as the different types of chemical changes and the different signs for identifying whether or not a chemical change has happened. So let's get started. We are surrounded by matter. And remember, matter is any substance with a mass and volume. And also, matter is made up of particles, atoms. The water in a water bottle, the apple in our lunch, the air that surrounds us are all examples of matter. But they don't always stay the same. We can open a water bottle and that water inside may evaporate, or we may drink it and it go through our body. We can cut an apple, maybe take a chunk out of it and chew it, and it goes through our body and comes out something completely different. Or we can leave it to the air and it'll change color like this one. So as you can see, all matter can undergo changes or transformations. And so we're going to talk about that first. Let's dive into physical change. What is a physical change? Is it A, a change that creates new substances? Is it B, a change that does not affect the nature of a substance? C, a change in the nature of a substance? Or D, a change that comes from physical exercise? The answer is B, a change that does not affect the nature of a substance. When we talk about the nature of a substance, we're referring to its particles, what it's made of. A physical change is a transformation that does not change the nature of a substance. No new substances are formed after a physical change. So if we take the example of water in 3 different states, you can see that the water molecules in ice, in water, as well as in gaseous form are all identical. They're just organized differently. And so as you can see, the physical change does not alter the nature of whatever substance is involved. It's kind of like when we have a sheet of paper and you crumple it up. Paper's still paper. It's still paper regardless of its shape. There are 3 types of physical changes. There's the change of shape, change in state, and the preparation and separation of mixtures. Our first type of physical change is change of shape. So a change of the substance's shape without changing its nature or characteristic properties is where we have a physical change. And remember that characteristic properties are used to identify a substance. So over here, you got a couple of examples of characteristic properties like melting point and boiling point and density. Those are all things that will help you identify a substance. So for example, if I take copper and I squeal it up into I bend it, it's still going to have a melting point of 1083 degrees Celsius, and it's still going to conduct electricity fairly well. If I take a bottle of water and I pour it into a glass, the water in the glass is still going to have a boiling point of 100 degrees Celsius and a density of 1 gram per centimeter cubed. So basically, a change in shape just means that it's changing form. It's not actually changing any nature of a substance. The copper wire is still copper wire, and the water is still water. It just changes shape. Our second physical change is change of state, or phase change. And that is a change in the organization of particles. So we have 3 states of matter: solid, liquid, and gas. And there are 6 phase changes. So fusion, sublimation, and vaporization all require heat and energy to be absorbed, and solidification, deposition, and condensation require energy to be released. And so if we take an example like butter, and we put butter in a pan, and we put it over heat, the butter is going to go from solid to a liquid state. The butter is still butter, but its state is changing. Here we have air. We have water molecules in the air that will condense. Energy will be released and they will cool off. And then we get water droplets, rain. So also water is still water, except now it has changed a state. So remember that in this instance, even though the organization of the particles will change, the particles have still remained the same. The nature of the particles do not change during a state change. And finally, our third physical change is the preparation and separation of mixtures. So remember, a mixture is a combination of 2 or more substances. And when you mix those 2 or more substances together, sometimes they mixed up evenly, sometimes not so much. So making a mixture, you can add, for example, vitamin powder and water, and you'll see that they mix up quite well and they form this mixture. But you can also separate mixtures so they go back to their original parts. So if you take mud and water, you can separate them into their respective parts, which are mud and water. Sugar is dissolved in water. This is a physical change. True or false? The answer is true. Dissolving a substance as water is usually considered to be a physical change. And for the purpose of this video, dissolution will be considered a physical change. But it's always a good idea to check with your teacher just in case. And there you have it, the 3 types of physical change. But here's a hint. Physical changes tend to be reversible. So you can separate oil and vinegar, you can straighten out a pin, and you can refreeze icicles. Something to keep in mind. And now it's time to talk about chemical change. Chemical change is a transformation that changes the nature of a substance and its properties. New substances are formed after a chemical change. So during a chemical change, what happens is that the particles break apart, rearrange themselves, and form a brand new substance. And in order to see if a chemical change really took place, what's really cool is that you can look for evidence, like a detective. So when you cook meat, when gas is combusting in a car, or even in our own bodies, chemical changes occur. So now let's look at how we identify if a chemical change happened. We look for evidence. You don't have to be a scientist to point out and see if a chemical change has occurred. The first thing that you can look for is a color change, and an extreme color change, like something that really hits you as, wow, that's different. An example would be if we were cut open an avocado. If you leave an avocado out in the air, it's going to react with the oxygen in the air and change color. Also, the change in texture and sometimes in odor can also tell us that a chemical change has happened. Another type of evidence to show a chemical change is the emission of light. So if I were to take, for example, a glow stick and crack it, the substances within that glow stick are going to mix up and produce light. Chemical changes are often accompanied by a temperature change. So either energy is going to be absorbed and the substance heats up, or energy is going to be released and it cools off. So for example, a fire. A fire, you take wood and oxygen, and the byproduct of that is going to be heat, as long as a little bit of change in color and sometimes sound energy. So that is also an example of a chemical change. Gas formation, or effervescence, is also another evidence of chemical change. So for example, if we take citric acid that is mixed with baking soda, we get a bath bomb. And we all know that when you put that in water, what happens is that the water, as well as the chemicals that are in the bath bomb, create that popping sound and that gaseous bubble sound that we get from a bath bomb. And finally, our last evidence of chemical change is precipitate formation. So this happens when 2 solutions are mixed together and they mix up their particles and they create a brand new substance that's in the form of a solid called a precipitate, which is our last and final example of a chemical change. But I have a hint for you. Chemical changes tend to be irreversible. So we can't actually make the avocado green again, and we can't go back and make the wood that was burned whole wood again. So just keep that in mind whenever you think of a chemical change. If you're in secondary 2, you might have to know a little bit more about the types of chemical changes. So let's go over them together. The first one that we're going to talk about is synthesis. And synthesis is a chemical change where several substances combine to form a new, more complex substance. So for example, we have photosynthesis in plants. And when that happens, we have carbon dioxide that mixes with water, and it forms glucose, which is this big molecule, plus oxygen, which is brand new. So as you can tell, we have a chemical change here. We had substances on one side of the equation. They rearranged themselves to form brand new substances on the other side of the equation, which was glucose and oxygen. The second type of chemical change is decomposition. It's a chemical change where a complex substance breaks down to form simpler substances. So for example, we can take hydrogen peroxide. Hydrogen peroxide breaks down into water and oxygen, but hydrogen peroxide will break down when exposed to sunlight, so that's why it's stored in a darker bottle. Our last type of chemical change is oxidation. Can you guess what it means from its name? What is oxidation? Is it A, a chemical change that requires oxygen, or B, a chemical change that produces oxygen? The answer is A, a chemical change that requires oxygen. Oxidation is a chemical change that occurs between a substance and oxygen, or a substance with similar properties. So for example, we could take iron nails, and if we put them and mix them with oxygen and probably some water vapor or something, we'll get rust or iron oxide. And that's an example of oxidation. Oxidation also helped the avocado turn yellow, which is why it's considered a chemical change, because we can't reverse it. Finally, we have combustion. It's an oxidation change where a lot of energy is released. For example, burning propane releases a ton of energy and a ton of heat through the form of carbon dioxide, water, and energy. And then we also have cellular respiration. And cellular respiration takes glucose and oxygen and turns it into carbon dioxide, water, and energy. So the thing I need you to remember about combustion is energy. It produces a lot of energy. And we're done. So a couple of things I want you to keep in mind. Physical change doesn't alter the nature of a substance, but chemical change does, and a new substance is created. There are different types of physical change, and there are different types of chemical changes. And there's different types of evidence to help you identify whether or not a chemical change took place. If you need any extra help, there's also a change in state video, so you can check that here. There you go. Don't forget to keep watching, and I'll see you next time.